Hi everybody. So today we're going to talk about weird cameras. Weird cameras. So this is like a chocolate bar size USB 3 camera, and it's Intel RealSense T265 camera. The idea behind this camera is quite simple. It has two fisheye or wide angle, extreme wide angle cameras, an algorithm to perform a stereo that in a way detect the an object for a feature point I've seen in the Booth CV or the KLT feature points that that edge of the the box or the table I'm sitting in this lens is actually the same feature point here, and by interpolating their relative difference or the angle between them have some sort of depth. But this camera is no way near kind of a depth camera. It's a tracking camera. It's more of a I'm a robot, I want to know my path, I want to go back. I'm a vacuum cleaner, I clean the room. I don't really care what is the shape of your room. I don't need to map it actually. I just want to know how I'm repeating back. I'm a drone, I've done that. Now I want to go backwards. Let's demonstrate that. I'm starting the camera, and while starting, you see the image of the camera, and I will be moving it a little bit, and then you can tell that it actually track my movement. Let's do that one more, and now, let's do the same box above that. Okay, so this is me being not so accurate, but yeah, you can see where I'm going, and in 3D you can see the two squares I've done, and maybe a circle would be better. So I'm doing a circle, and you might say it's not a circle, but if I look at it in 3D, then it looks like a circle. Okay, it's quite accurate. If I'll take zoom out a little bit, and I can move a little bit more, then you can see it all goes back. So whenever you see a green line and not a yellow line, or red, heaven forbid, this is meaning or representation of a good tracking, meaning the view of the camera has enough details for it to localize itself with respect to its last position or its recorded position. So consider the following thing. I have a view. I remember it. I store it in my memory. And whenever I see a related view to that, I say, okay, I know that. It resembles me, the place I've been there. But I might be looking for a different angle. The same thing happened here. It's called a SLAM algorithm, but mostly a visual SLAM algorithm. And the way to understand that is to look at a 2D representation of that. So here we see the left camera and the right camera. And you can see how my hand is being interpolated, or it looks different from the left angle or the left lens and the right camera or lens. But if you look at the camera, the computer, which is only like 1 feet or 50 or 30 centimeters from my camera, it looks quite the same, but not exactly. So we have an extreme wide angle camera, and yeah, if it's close enough, yeah, this seems like a recursive thing, then you can tell there's some difference. By that, and by using a fast SLAM algorithm or visual SLAM algorithm, the computing card or the computing board in this camera allows it to compute its position and track. It has an IMU, and you can see the IMU in the lower part of this image, and you can see that it moves with that. Using that, even if there's a momentary blockage or there's some sort of a noise or something like that, it's still being able to have the angle, so the process of alignment or calibrating this image to the recorded image is easier, because at least the 3 degree of freedom of the orientation could be tracked using the IMU and not just the visual. If I have a proper light in my illumination of the region is is properly being detected by the two cameras, then performing a stereo is quite easy. Yet, often the lights are not too, well, in natural cases, the lights might be dimmed, or can work in dark, or consider a robot, it might work in total darkness. So there is this notion of lighting, and the idea is simple. You have like a laser flash or dots of those laser flash, and prime sense cameras, those all the Xbox 3D cameras were using that. Time of flight cameras are kind of, or LiDARs are kind of complicated, but the main physical idea behind it is that if I could like flash a light and then count the time that it took to the light to go all the way to the wall and then back, and then interpolate that into the speed of light, then I can have the distance. Well, easier said than done, because this is actually complicated.